Okay, so we're going to take a nice turn into probably what most of you thought we were going to be going over in anatomy and physiology. So today we'll be starting chapter 6, which is bones and bone structure. So what's nice about this particular part of the course is that, screen sharing is paused, is that we have the classes kind of broken down into a couple different kind of sections or parts, and so this second section that we're starting now is going to be focused primarily on bones and muscle. And so right now we'll be starting on bones. We'll start to talk about individual bone structure, how bones are, made and remodeled, and then I think in part 2 we'll probably talk about repair, and then we'll move on from chapter 6, and then we'll start talking about the skeleton, memorizing bones and things like that, and then we'll transition into muscles and kind of the same situation there. We'll be talking about individual muscles, tissue structure, and then move into larger muscular systems within the body. So again, this second section of the course is probably what people most think of when they're thinking about anatomy and physiology. So bear with me, recognize that this is where this chapter is probably a little bit of more physiology than structure, but there is going to be a lot of terms and memorization. So please make sure that you're staying on top of that as much as possible. I'm going to try to point out terms that you will need to know versus terms that maybe you don't necessarily need to commit to memory. Because of this course, I want to not get lost. I want there to be kind of a bigger scope. And so I'll try to kind of highlight words that are definitely going to be part of the vocabulary that you're going to need to know. And I think this particular lecture is going to need that type of highlighting, because there's a couple of figures that I'll pull up here where you'll probably be a little overwhelmed, and I'll try to just circle the particular words that you're going to be most focused on. So don't get intimidated or lost in some of these figures. Make sure that you're just using them as the big view vantage point for things like cross sections of bone. And like I said, I'll try to keep it as focused as possible in terms of things that you'll need to know, because I know that's always a big concern, especially coming out of an exam. Okay, so the study guide questions for this particular lecture is going to be, talk about the 6 main functions of the skeletal system: structure and function of long bone, compact and spongy bone, why bone tissue is classified as connective tissue, cellular composition of bone tissue and the functions of each type, structure and function between compact and spongy bone, blood and nerve supply of bone we'll talk about at the end, the purposes of bone growth and remodeling, and intramembranous and endochondral ossification. So we have a big, tall order today. Okay. So just make sure you're staying on top of all the assignments. Make sure you've answered the study guide questions for chapter 6, that you complete by midnight Friday the quiz for chapter 6, and then the next following week, kind of almost like a week and a half from now, make sure you've completed adaptive practice for chapter 7. And again, that's kind of the next step in the process. And hopefully, because we're staying, with common due dates and things like that, you're kind of falling into a rhythm. I may send out a reminder email Sunday nights just to let you know that you need to complete your adaptive practice by Monday at midnight, that your quiz is due on Friday. I think hopefully that'll help people kind of be like, oh yeah, I gotta get that done. Okay, so in terms of this particular lecture, we're going to start by talking about the functions of the bone system. So if you are following along and reading your textbook, recognize that there's a nice introduction about essentially what the functions of bone are and such. Sorry, hopefully you're not getting the things that are popping up on my screen. And part of that introduction is talking about things like bone density and how different types of stress can affect bone density. So when astronauts go up into space, they're no longer having the stress of gravity put upon their bones, and so they can come back with up to a 20% decrease in their bone density after being up in space. Versus if you look at an athlete who's, very strenuously using their bones and the essentially kinetic and the physics behind creating higher bone density because of the musculature that they're forcing and the force and the stress that they're putting on their bones, actually have increased bone density. And so throughout this chapter, we'll talk about why that is and how stress on bones alters their bone density. So this is kind of a fun fact that the textbook kind of creates as an introduction. So as with most chapters, it's good if we start off with definitions of what we're talking about specifically. So in the case of bone, I'm just reminding myself I need to slow down. Bone is an organ that's made up of several tissues. So it's not just bone as what we think of it as. You've got bone, you have cartilage, you have dense connective tissue, adipose tissue, for you, it may be more commonly thought of as fat tissue, and nervous tissue, again, that's going to be nerves kind of innervating the bone and obviously causing communication between the bone and the nervous system. The entire framework of bones and their cartilages constitutes the skeletal system. If we are going to talk about the study of bone, we would be studying osteology. You'll notice really quickly that you'll see the root word osteo a ton. Osteopath would be a doctor who studies bones. And so osteo, again, if I think we go back to either Greek or Latin, you're going to see that osteo is going to be bone. And for those of you who are medical professionals, studying Greek and Latin probably wouldn't be like the worst, I guess, a hobby to pick up, just because so much of medical terminology is based out of those root languages. Okay, so the first kind of study guide question we had here was the functions of the skeletal system. So the first is going to be to provide support. So if we look at things like the soft tissues, it's going to need to support those soft tissues. It's going to be attachment points for tendons as well. So when we talk about the interaction between muscles and bones, in order for that force to be created, that for muscles to generate force and thus motion, it's going to have a connection point to bone. And so this is going to be an additional example of how the skeletal system provides support. It also protects internal organs. So we see things like brain and heart. So brain would obviously be the skull. And the heart would obviously be the rib cage, and those are going to essentially provide housing systems for some of these, softer organs that are very important for function and for survival of a human. And so it's important that the skull has a certain amount of structure and is able to withstand force or trauma. And same thing with rib cage. In order for blood and oxygenated blood to circulate through the cardiovascular system, the heart needs to be protected by the rib cage. And so again, it protects those internal organs that are very important for survival. It also assists in body movements, which we kind of talked about in point 1 in conjunction with muscles. So again, it's that attachment point to the bone that allows the muscle to provide force, and that helps translate into motion. Another thing that's important for the skeletal system is it plays an important role in mineral homeostasis. So it stores and releases calcium. If you remember when we talked about vitamin D and how vitamin D is absorbed through the skin, and it plays an important role in calcium in the body. So this is, again, where that interaction is going to take place, and you're going to have the release of calcium in the body. So in terms of how much calcium is stored in the bone, I think it said in the textbook that 99% of the body's calcium is actually stored within bone. So it's a huge repository of calcium within the body. Another function for the skeletal system is within bones, you have participates in blood cell production, or hemopoiesis. So for more blood cells to be made within the body, we have to have certain locations within the bone for those blood cells to be made. The red bone marrow is going to be the source for that. It also is going to play an important role in storing triglycerides and adipose of yellow marrow. So anytime you see adipose, automatically think fat or lipids when we talk about those macromolecules. And so those are going to be another place in which we have energy storage within the body, is that adipose cells in the yellow marrow. So these are, again, the 6 functions of the skeletal system. And I think this is point 1 in your study guide. So it's worth just maybe looking at this particular slide for a second, making your own notes over it, and then maybe even referencing the textbook as well for any additional notes you might want to add. Okay, so the structure of bone. So we talk about bone structure here. We're talking about the structure of just an individual bone. We're not going to be talking about kind of the bumps and curves on the bone quite yet. We're just going to be talking about essentially cross sections of the bone and what the bone is composed of, like the different cell types and such. And so what makes up a bone? Okay, so long bone has several different parts. So if we look at a long bone, think of your femur. It's probably the easiest kind of visual for folks to have. So think of your femur as that long bone that's got those two kind of knobby ends, and we'll obviously learn more direct terminology about what those are called. So if we think about the long bone, kind of the center of that long part of it, that's called your diaphysis. And so the diaphysis is going to be the bone shaft. It's the longest part of the bone. We'll talk about kind of how the diaphysis is generated, what it's composed of, the different types of cells that are in that area, and kind of how the structure looks slightly different than the ends of the bones. So if you look at that long femur again, you've got their diaphysis, which is the long part, and then you have two epiphyses that are both ends of the bone that are located at the joints. And so those are going to be important areas of, we'll see in a second here, where you've got different types of bone, both compact and spongy, but those epiphyses are both at the ends of the bone at the joints. Then you have your metaphysis, which is the region between the diaphysis and the epiphysis, and that's kind of almost like a transitional region between that long bone and the very end of the bone. In there you'll have a metaphasal plate, and this is going to be a place that allows for growth. So if you think about like your growth lines in your bone, we'll talk more about that again a little later on in the lecture. And then you, in addition to that, you have articular cartilage that is covering both epiphyses. This reduces friction and absorbs shock between bones, and so it's important when we think about connecting points of bones, kind of how they're coming together. So remember last chapter, or the last chapter? No, maybe 2 chapters ago, we talked about synovial fluid and how that, creates the fluid for joints. And so another thing that's going to be aiding in that friction and absorbing shock between the joints, again, because you've got those two hard things coming together, you want to be able to cushion them. So articular cartilage is going to help absorb some of that shock between those two bones. The periosteum is going to be the connective tissue surrounding the diaphysis. So again, the diaphysis is that long part of the shaft. So if we draw a bone, this is just my very cartoony picture of what a bone looks like. Again, this is going to be your diaphysis, and then this is going to be your epiphysis up here, and then this is going to be metaphysis, and we'll again see much better drawings of this in the future in future slides. I'm just going MEMD. Epiphysis, metaphysis, and diaphysis. The periosteum is going to be the surrounding tissue for the diaphysis, so it's going to hang out here as well. So we'll look at more of the function of that in following slides. And then you have your medullary cavity. This is the hollow space within it. So if you look at the inside of a bone, you'll notice that there's this hollow space within it. And so that's going to be the medullary cavity. And we'll talk about kind of the types of cells that occupy that, as well as some of the vasculature or blood vessels that go in there as well. And then the last thing you have here is your endosteum. That's a thin membrane lining the medullary cavity. So again, that medullary cavity is in that long part of the bone of the diaphysis. And so you have your endosteum that's lining that. You're going to have bone-forming cells that are going to be located in your endosteum, as well as a small amount of connective tissue. So those are going to be lining that endosteum. So this particular slide has a lot of information on it. I would recommend maybe creating your own drawing, kind of like what I've done here, and then maybe taking it to the next level. I'm not taking it to the next level because it's kind of hard for me to draw on these slides, but again, maybe just draw your bone and then label your epiphysis, metaphysis, and your diaphysis, and then also the other, your periosteum, your medullary cavity, as well as your endosteum within your drawing of your bone. Again, I am a huge visual learner, so drawings are something that I find helpful, and I think that maybe you will too. So just as you're going through this lecture, maybe just get a blank sheet of paper and just draw this out as part of your notes, and maybe it'll make things a little bit clearer, because we do have a lot of different, like I said, terminologies we'll be going over here. And so the sooner you can kind of make the link between the terminology and what I'm referring to, the easier it is to not get lost when we get into subsequent slides here, because this is, again, kind of your first slide where we're introducing a lot of different terminologies. So make sure you kind of have a clear understanding of where each one of those is coming from. Just want to check my notes and make sure that I'm not forgetting anything that I want to add here. Again, the periosteum is connective tissue surrounding the diaphysis. We'll talk about how there's a tough outer fibrous layer and an inner osteogenic layer, that thicken but don't necessarily lengthen the bone. So again, when we talk about the periosteum, that's going to be thickening that bone, that longer part of the diaphysis, and not necessarily lengthening it. It's going to be making it kind of wider. So we'll talk about that a little bit later as well. So just wanted to double check and make sure I wasn't forgetting anything. As always, if you have opened up your PowerPoint, this is a great opportunity to maybe click on this link. It will provide a video. Obviously, I'm always giving you my word description of what's going on here, but sometimes these videos can be really helpful in terms of watching processes. So if you found these videos helpful, this is, again, another opportunity for you to check them out. Okay, so instead of my crazy cartoon that you saw in the last slide, this particular slide is much better. I think it's showing these different parts of the bone. So we'll start with kind of the first part of what we talked about last slide, which was your diaphysis, which is that long part of the bone. Again, this is the humerus, and the femur would probably work just as well, but this is a description of the femoris. You have your metaphysis here, which is going to be kind of this middle part of the bone, and then your proximal epiphysis, and you can see your proximal and distal. If we remember those terminologies in terms of describing orientation, they're being applied here, which is kind of nice, right? And you see that there is similarities or mirror images of those on each end. You've got your proximal and your distal epiphysis, and your proximal and distal metaphysis as well. So again, as you're learning these things, sometimes it's nice to start with the big picture, the big kind of structural components, and then zooming into each one of those structural components and looking at what they're composed of. So if we look at the, let's say, diaphysis, we'll see that there's that endosteum, and that lines that medullary cavity, lines the assists in the production or the nutrient artery. Sorry, the nutrient artery is its own thing. I need to not circle that. The endosteum there lines the medullary cavity, and we'll talk about the medullary cavity here in a few other slides. Medullary cavity contains yellow bone marrow in adults. Again, we talked about how the yellow bone marrow has adipose tissue in it. You can see you have your endosteum, which we talked about. Oops, stop circling the nutrient artery. Medullary cavity, and then your periosteum as well. And that periosteum is that connective tissue that surrounds the diaphysis. So these are all terms that we just saw on the last slide, and this is giving you that nice picture of all of them. So again, these are all things that make up that diaphysis. In a few slides, we're going to define what compact bone is, but here it's just kind of introducing the idea. The metaphysis, again, what you'll see here is that there is an epiphyseal line. That epiphyseal line is kind of what we think of when we think of as the growth plate. That's where bones are going to lengthen. And so we'll talk about that and kind of the process of how bones lengthen here in a bit. If we look at the epiphysis, you can see that you have articular cartilage on the outside. Spongy bone is going to also be contained in the epiphysis, kind of like the heads of the bone. And you can see that the red marrow looks slightly different than the compact bone. So we're going to talk about spongy bone and compact bone as being two different types of bone. So these are terms we're going to define in the upcoming slides, but it's a great place to introduce those concepts here. Okay, so like I said, slides like this can be kind of a little overwhelming. So just start by labeling the things that you know, define those, start with diaphysis, metaphysis, and epiphysis, just those different sections of the bone, and then break down those sections into kind of those different components that compose them. The diaphysis obviously has the endosteum, the medullary cavity, and the periosteum. as you can see here, and then your metaphysis is going to contain your epiphyseal line, and then your proximal epiphysis has your spongy bone contained within it. So, like I said, some of these are going to be defined in subsequent slides, so don't feel like if you don't know exactly what all these words mean that you're lost. Don't worry, we're going to hopefully by the end come back, but I'm introducing them here so they start to kind of seem familiar and you're just not like, oh gosh, where did that come from? Okay, so continuing kind of our discussion about the structure of bone. So when we talk about the structure of bone, like I said, there are basically two different types of bone that we'll talk about. We'll talk about spongy bone and we'll talk about compact bone. So 1, 2. So spongy bone and compact bone are very different in terms of kind of their structure and function. So compact bone is going to be like the stronger bone. It's going to be have very few spaces in it. So you can see here that compact bone, you don't see really any kind of space in there. It's a very strong. It's going to make up the diaphysis of this long bone. So you can see that that compact bone is there, but you'll also see some compact bone on the outer part of the epiphysis and metaphysis as well. You'll notice here that in contrast, spongy bone is kind of far more, has a lot more holes in it. As we see here, you can see all those tiny little holes. It's in the interior of bones. It's protected by the compact bone. It creates some lightness to our bones. If our bones were just super dense, it would be very hard for our muscles to move our bodies. So there needs to be some kind of these large pockets of air. So that's part of the function of the spongy bone. And again, we get the ability to kind of use some of the terminology we just saw here. You can see that there's the medullary cavity of the diaphysis, again, that space in the diaphysis, and then we have our metaphysis, which is, again, that's space between the diaphysis and the epiphysis, and then you have your epiphysis here, and then your epiphyseal line, which we'll talk about in terms of growth and lengthening of the bone. Okay, so again, just the big picture here, spongy bone and compact bone are the two types of bone we'll be talking about in subsequent slides as well, but this is kind of a nice introduction to showing both of those two different types of bone. Okay, and again, we keep using the same terminology again and again, and hopefully every time we use a terminology, you become more comfortable with it. So the diaphysis is that long shaft, the epiphysis is again, metaphysis is going to be that intermediary area. Okay, so histology of the bone. So when we break the bone down, what is it composed of? What are the different types of cells? Essentially, what is it made up of? Okay, so the bone contains a ton of extracellular matrix. If you remember, we talked about that a few chapters ago, surrounded by widely separated cells. So the extracellular matrix is composed about 15% water, 30% collagen. Remember, we talked about collagen before, and 55% crystal mineralized salt. Kind of the main one that we obviously talk about a ton is calcium. It's actually calcium phosphate is going to be the particular mineral salt that's important here. That calcium phosphate eventually undergoes the process of calcification, so it gets hardened, it becomes calcified. This calcification process is going to require not just calcium, but also collagen fibers. And so those collagen fibers kind of help provide the structure, and then the calcium kind of crystallizes around it. The collagen provides some flexibility to the bone, and then the calcification or these calcium salts kind of create the hardness to the bone. And so again, calcium is what helps create the hardness of the bone in terms of the overall structure of it. So the bone is also composed of a good number of cells. And so that's what we're going to talk about in the next slide. So what are the different types of cells that make up the bone? Okay, so again, this is a lot of terminology, so please take your time, slow it down. If you need to pause at any point in the lecture, take your own notes, read through the slide, look in the book, read through the slide again. Please feel free to do that, because it's important that you feel comfortable with these terms, because we're going to start to use them more and more throughout this lecture. Okay, so the 4 types of cells. So we'll just kind of start at the beginning, like where does bone start. And you have your osteoprogenitor cells. So your osteoprogenitor cells are stem cells that are going to continue to replicate and create new cells to make bone. So bone stem cells differentiate into these other types of cells. So this is kind of where everything starts. This bone cell can basically change into any different type of bone cell, and then go through the process of maturing and then become kind of the mature bone cell that makes up the bone structure. So your osteoprogenitor cells are constantly dividing. Think of, again, when we talk about mitosis, these are the cells that are constantly going through mitosis, and more of those cells are being made. Okay, osteoblasts. So osteoblasts are the bone building cells. These cells build bone. Now, it's important for you to recognize at the beginning here that bones are constantly being made and remade and what they call remodeling. So you always have new bone cells that are being made and old bone cells that are being broken down, and so there's this constant kind of turnover of bone, and this process happens, you know, as bones are forming, but then throughout the rest of the lifespan of the bone. So osteoblasts are the bone building cells that secrete matrix. They also initiate calcification and the hardening of bone. So think of the word blast as bone building. Blast, building, okay? These osteoblasts are going to mature into osteocytes, and these are going to be mature bone cells. These mature bone cells no longer undergo cell division, so they are in what we would say not mitotically active. And so osteocytes are just, again, mature bone cells, and they're doing their bone cell thing, kind of creating that structure. Okay, next you have osteoclasts. Think of osteoclasts as carving out. So these osteoclasts remodel bones and cause them to release calcium. So sometimes we need calcium from our bones, and so these cells are kind of the cells that break down the bone and release that calcium. It's essentially the result of 50 monocytes, and so when we talk about where these cells kind of come from, these cells all come from bone cells, kind of the original cell that makes all the rest of these cells come from kind of a bone cell progenitor, and this is a different progenitor cell. This comes from a different place. And so these osteoclasts remodel bones and cause them to release calcium in the endosteum, and they basically have an enzyme that they release to break down bones. So osteoblasts build, so osteoblasts will go build, and osteoclasts carve, so they break down bone. So building and carving. So when we're talking about bone remodeling, you can kind of see how these two types of different cells are going to play a role, right? You've got one cell building, you've got one cell carving, you have one cell building, you've got one cell carving, and so they're able to kind of balance that out, that remodeling process for bones. Okay. Let's make sure we get osteoprogenitor cells, make more of themselves. Osteoblasts build. Osteocytes are just mature cells doing their mature cell thing, and osteoclasts are going to carve out bones. Okay, so these are pictures of what the cells actually look like. You can see here that the osteoprogenitor develops into an osteoblast. The osteoblast forms extracellular matrix. It's, you know, doing that extracellular matrix secretion thing. And then your osteocyte just basically maintains the bone cell tissue. And when we look at mature bone cross sections, we'll see kind of where the osteocyte is hanging out, you know, like where is it doing its mature bone cell thing. So this is from bone cell lineage. So like I said, we're looking at where these bone cells come from. You can see the maturation process, or how these cells go from immature to mature right here. And these are all, again, bone cell lineage cells. That's where they're coming from. And then kind of coming from a different whole set of lineages, coming again where it comes from in the body. This is from white blood cell lineage, so this is kind of a cell that's coming from immune cells. This osteoclast is going to function in resorption and the breakdown of extracellular matrix. Again, think of osteoclast carving things out, and it's going to be has this ruffled border, which is part of just its structure. So again, osteoblast builds, osteoclast breaks down, osteocytes are the mature cells. This again is the very 30,000-foot view of these bone cells, but we're going to use these cell types in terminologies and descriptions for future slides. So just, I know I keep harping on learn the terminology, but I just want to make sure you have a very firm grasp of these words before I start using them very loosely in subsequent slides. Okay. Okay, so what's nice is that down here you have these beautiful SCM pictures of each one of these cells, because scientists like pictures of real things. So not just cartoons, they really do look like that. They do kind of look like the cartoons, right? Which is nice to know. Okay. So in previous slides, we talked about the different types of bone. We talked about how there is compact bone and how there is spongy bone. So like I tried to introduce at that point, the spongy bone is good at providing protection and support. Spongy bone is found in areas like your skull and your mandible. Let's see. Oh, sorry, I just circled compact bone. So your spongy bone is found in things like your skull and your mandible, and so it's lightweight and provides tissue support. So like I said before, our bones can't be completely dense, completely solid, or we wouldn't be able to move. And so spongy bone is found in those locations where it's nice to maybe have a little bit of lightness to the bone. Yeah, but the spongy bones are also encapsulated in a layer of compact bone generally. So compact bone is good at providing protection and support. We look here, we can see compact bone as part of the diaphysis of that shaft. So going back to those, terminologies that we learned at the beginning. So you have your diaphysis, your metaphysis, and your epiphysis. And so this is going to make up a bulk of the diaphysis, and it's going to be a very strong type of bone in terms of protection. So again, I just wanted to revisit spongy bone and compact bone. And we're going to actually look at the different histologies of these two different types of bone. You'll notice that they looked different when we look at them on the screen, and then in the subsequent slides we're actually going to look at how they look different. Okay, so again, if you're a visual learner, you like videos, please make sure you click on these. They'll kind of revert you to videos in Wiley Plus, and this could be really useful. Okay, so this is one of those slides that you look at and you're just like, whew, there's a lot on this slide. So just take a deep breath. I'm going to start pointing at things that you can kind of not pay attention to, and then we'll focus on the things that are kind of more important. So let's start with terms that we know and things that look familiar. So if you look at kind of how things are broken down here, you can see that this is compact bone. So we're looking at a cross section here of bone. So you can see there's compact bone. So this is all compact bone structure. And then let's come down here. We'll circle that this is the spongy bone. So we're actually going to zoom in and we're going to look at spongy bone in the subsequent slides. So for this portion of it, just going to X out the spongy bone, because we're gonna go into that more in the following slides. So just don't really worry about that right now. Okay, so let's focus on compact bone, and you'll notice that there are these set of kind of circles that are present here, right? You can see that there's circles all located all around blood vessels. You see that blood vessels are kind of a part of the central canal. So you can see that is called the osteonic canal. And then these, the way that those blood vessels get in there is through the interosteotic canal, or also called Volkmann's canal. And then you can also see you have perforating fibers here. Other terms that we saw in previous slides were things like the periosteum and the periosteal vein or the periosteal artery. Don't worry about that for this slide, because we're going to go into that a little bit later. But let's kind of, again, just focus on this set of circles here. So this set of circles, if we look at them, if we look at an entire set of circles, that's called an osteon. So in terms of this figure, let's just start to number things that are relevant or that you should kind of know. So 1, 2, spongy bone, compact bone, and then this whole set of circles here is called an osteon. So we can see here in that osteon, you've got this set of concentric circles around those blood vessels, and those are called concentric lamellae. And you can see how those lamellae are organized in a very specific way. If we zoom in even further on those lamellae, you'll see that there's that, that mature bone cell there, that osteocyte that's present there. And if you look at that, we look at this zoomed in portion of that, there's caniculi, which is going to be that space where those extensions out, and lacunae, which is going to be that extracellular space. Now, we're going to look at this again, maybe a little bit more zoomed in a subsequent slide, so don't get too bogged down. So for this slide, I have numbered things to take note of or to be able to label on this slide. So we've got spongy bone, compact bone, osteon, which is 3, and then the concentric lamellae, which is 4. We're going to go into this in subsequent slides. So for this particular figure, don't worry about it. So I'm going to go ahead and circle in red as well. 1, 2, 3, 4. Okay, and then like I said, some of these other terms we're going to see at subsequent slides, but for this one, focus on those 4 things that I've just circled there. Because like I kind of introduced this slide, there's a lot going on here, and I don't want you to get bogged down in it, but I do want you to see how all these things are related, so the big picture is important. So just make sure that you feel comfortable with those 4 kind of terminologies, because we'll see these other terminologies that we're going to use on subsequent slides. Okay, so like I said, we have spongy bone and compact bone. So if we focus and just zoom in on compact bone, if you zoom in and focus on spongy bone, you have these trabeculae, which are kind of like these knobby pieces of bone that you see here. So you've got spaces for red bone marrow. That's going to be the spaces that are important for the creation of blood cells. And then if we kind of do a cross section of these trabeculae, you can see this is the cross section. Zoom in over here. You can see we'll start with kind of the mature, cell. You have your osteocyte here. That is your mature bone cell. You have your osteoclast here. That's going to be your cell that is going to be, carving it out and breaking down the bone and possibly releasing calcium. And then you have your osteoblasts, which are your bone building cells. You can see that those osteoblasts are lined along the trabeculae of new bone, so they're kind of lining that whole area there. And then you can also see that you have your lacuna, which is that region there. Those are going to be the spaces alongside the osteocytes. And then if we look at the lamellae are going to be these concentric kind of circles that we see around this area that you see here, circular plates of extracellular matrix. So that's the extracellular matrix that you see there. And then kind of you see how that there are also these lines extending from the center. Those are your caniculi, and those are going to be filled with extracellular matrix. And so you've got your set of concentric rings running like this, which are going to be, circular plates of your lamellae, and then you've also got these lines extending out from those, which are going to be your caniculi, and those are going to be filled with extracellular fluid. And kind of interspersed within there, you have your osteocytes, and those cell bodies are kind of interspersed, and then you can see the other types of bone cells represented there. So like I said at the beginning of this, there's a lot of terminology, so please make sure that you take some of these images, redraw them, start labeling them. As you label them, make sure you maybe also write like kind of a one sentence explanation of what those things are. Okay. So that's again kind of the structure of bone. In terms of how the bone gets blood supply, there are different arteries as well that are supplying blood. So when we look at this particular slide, I can almost break it down into two different types of blood supplies. So these periosteal arteries enter the diaphysis through the Volkmann canals, which I pointed out in a few slides ago, and they are accompanied by periosteal veins. And then the nutrient artery enters through the diaphysis through a nutrient foramen, and nutrient veins exit through the same canal. So these two, the periosteal artery and the nutrient artery, we're talking about the diaphysis and blood supply to the diaphysis here. And then just recognize that the metaphysis and the epiphysis have their own arteries and veins, but we're going to focus on these kind of two, the periosteal and nutrient arteries on this slide, and then I'll point them out on the next slide. That's going to show you kind of where these arteries and veins are going into or vascularizing these bones. So make sure, again, we keep using these terminologies, periosteal, Volkmann's canal. You can go back to the subsequent or the previous slides and actually look at some of the where those are on those figures. So again, just break it down to whatever is the easiest possible thing for you. So just understanding where the diaphysis is and then saying, oh, the diaphysis relates to these two arteries, and then the metaphysis and the epiphysis have their own vascularization. Okay. Okay, so keep coming back to the same terminologies, diaphysis, metaphysis, and epiphysis. This is great, right? 1, 2, 3. You should know these by now. We've gone over them a few different times. Now, we just talked about in that last slide is you have your periosteal vein and your periosteal artery. You can see them coming in through here. Again, they are vascularizing the periosteum. And then if we look at the nutrient vein and the nutrient artery, they're coming in through the nutrient foramen. These are the, the blood supplies to the diaphysis. So this is all diaphysis. This is all occurring in that medullary cavity. Remember that space that is located in the diaphysis. And in terms of like the metaphysis and the epiphysis, what's nice about them is that they just have a single artery and vein that are causing the vascularization. So here you can see the epiphyseal artery, the epiphyseal vein, metaphyseal artery, the metaphyseal vein, and then we'll talk more about the epiphyseal line here in a second. But so you've got your diaphysis 1, your metaphysis 2, your epiphysis 3, and then your diaphysis you almost have like A, your periosteal artery, periosteal vein, which we'll do here, and then you have B, your nutrient vein, and your nutrient artery, which comes in through your nutrient foramen. And so you've got kind of A and B creating vascularization to your diaphysis, and then here you just kind of have your metaphyseal artery and your metaphyseal vein and your epiphyseal artery and epiphyseal plane. So what I'm trying to do here is break these down into kind of components where you can see that this all pertains to the diaphysis, this all pertains to the metaphysis, and then this all pertains to the epiphysis. And this, so hopefully breaking it down like that makes it a little bit more palatable. And maybe printing off your slides and doing these circling can also be useful as well. But again, this is just talking about the blood and nerve supply to the bone. Okay, so bone formation. Bone formation is exactly what it sounds like. How are bones made? So let's talk about that. Okay, so the process of bone formation is called ossification or osteogenesis. Osteo meaning bone, genesis being the creation of. Ossification is kind of the process of the bones being formed. It forms in 4 different situations. These situations should not be surprising to you. This should hopefully be like, oh, I can take a little mental break because I should think in your mind, when would bone be forming? Bone would be forming, as during fetal development, when a new human is being formed. 2, bones are going to be growing before adulthood. So bone growth occurs, all throughout childhood and can kind of cease anywhere between like 14 and 25 years of age. You've got bones continuing to grow until the points of time when bones remodel. So bone remodeling is kind of constantly occurring. Again, we talked about that a little bit earlier. And then when fractures heal. So if you have some type of break in the bone, when that break is being essentially healed, they're going to have the bone formation occur. So yeah, again, this should be a nice little mental break. Again, this is a little bit of a dense lecture. So hey, if you are watching this lecture and you're getting a little anxious, maybe now is a nice time to take a nice deep breath in, a nice deep breath out, oxygenate that brain, and hopefully it'll help you kind of focus for the last section of this lecture. So don't stress, just take your time. And if you need to pause while you're watching lectures, that can also maybe be really advantageous. Research shows that, the optimal amount of human focus nowadays is ultimately 20 minutes. So think maybe just watch 20 minutes of lecture, pause it, process it, take some notes, watch 20 more minutes of lecture, pause it, process it. So that can probably be very advantageous for you in some ways, because it allows you to really focus on the material. Because usually after 20 minutes, and I mean, this is for pretty much anything, your mind is just going to start to wander. And maybe you'll just think of like, man, that's a droning voice I hear. So yeah, it's just another study tip, take it or leave it. And it can be helpful just to watch these videos in kind of 20-minute stints. I know that makes it seem harder because then you have to come back to it possibly, but maybe just taking even a minute or two of break and checking your phone. I can't believe I'm telling you to check your phone or do something else for just a second and kind of reset your mind so you can come back and really focus on the material. Okay, enough of that. So bone formation, ossification, we just went over that side. Okay, so it has two different forms in which it occurs. It occurs in the intramembranous, essentially bone formation, and the endochondrial. If we think about the intramembranous, that's going to be bone formation from the mesenchyme. That's a type of cell. I'm not going to expect you to know exactly what the mesenchyme is. This is going to occur in the skull, facial muscles, and the mandible. So a lot of things that we see in the cephalic region. And then endochondrial is going to be more of the long bone, probably the more traditional type of bone formation that we think of when we think about osteogenesis. Okay, so intramembranous ossification occurs in flat bones when the connective tissue membrane is replaced by bone. So here we're kind of zooming in onto a flat bone of the skull, aka the mandible. Okay, so here you have your ossification center, your mesenchyme, your osteoblast, and your collagen fibers. So once the ossification kind of center has formed, you have those osteoblasts that are bone building cells, and so they're releasing that extracellular matrix and creating that growth for that bone. So you can see yeah, you're secreting organic extracellular matrix. I like how they say organic, like it would be inorganic, but I mean, I guess it could be. Okay, so step 2 is once that kind of ossification center has formed, you're going to have the process of calcification that occurs. So again, calcium and other mineral salts are going to be deposited, and extracellular matrix is going to harden. So those osteoblasts you can see is the newly calcified bone around that extracellular matrix is going to kind of harden. Those osteocytes are going to become mature in the lacuna. And remember, when we go back to look at kind of the structure of bone, where that's located. And so the next step is you're going to have the mesenchyme condense, and you have blood vessels that are going to be vascularizing this region of bone. So the formation of the trabeculae starts to form, and extracellular matrix develops into trabeculae that fuse to form spongy bone. So this type of bone formation is where we're going to see the type of bone formation for those spongy bone regions. But you still have blood vessels that are forming or that are going into those kind of holes in the trabeculae. So once that spongy bone has formed, you'll see that the periosteum is going to form around it. So the periosteum you can see here, the compact bone tissue is also going to harden and form around that spongy bone tissue that you see kind of lining the center. So again, intramembranous ossification, you've got your ossification center kind of expands to a certain point, and then you have it turning into spongy bone, and then that spongy bone gets encapsulated into compact bone with the periosteum also lining it. So this is probably the less typical type of bone formation that we see. We tend to see the endochondrial bone formation and a lot more types of bone. Okay. So bone formation. So endochondrial ossification replaces cartilage with bone. So you have the cartilage precursor. It's kind of like the blank slate, and then the bone kind of forms from that. And so this occurs with the developing embryo and fetus. And so similar to what we saw in the beginning when we talked about bone structure, again, you've got your diaphysis to the center, and your proximal and your distal epiphysi. And then you have perichondria that are lining it. So your cartilage is going to be kind of your precursor that you can see here. This is composed of hyaline cartilage. That's the specific type of cartilage. And then what happens is you kind of have this calcification that occurs from the center and then goes outward. So you have the calcified extracellular center in the diaphysis, and then you're slowly going to have the expansion of that calcification occur through the diaphysis and expand closer to the metaphysis. And then the epiphysi actually have a second ossification center that occurs there. So again, going from the center out in those kind of ends or bolts of the epiphysi of the bone, you have that secondary ossification center that occurs. So that primary ossification center, as it grows and expands, you see that it also leads to that medullary cavity down the center, which is going to be that hollow cavity, which allows for the vascularization of that area. So the development of that primary ossification region in the diaphysis replaced by most of the cartilage. So here you see that cartilage being replaced, and then the medullary cavity forms, and you've got the vascularization of the arteries coming in here. You'll see the presence of veins as well. So this is step 4, and then in step 5 you have the secondary ossification center occur in the epiphysis, and then also the vascularization into the epiphysi, into those kind of spongy inter parts of the epiphysis. So I guess the important things to recognize here is you have hyaline cartilage that's being replaced by calcified extracellular matrix that becomes mature bone, and that you have 2 ossification centers that occur both in the diaphysis and the epiphysis, and then they create those cavities. We'll talk about kind of how those cavities get made. If you go back and think about the different cell types of bone, you can hopefully start to predict what type of cell would allow for the bone to become hollowed out. What type of cell would lead to bone carving? Pause there, just think about that answer. What cell would lead to bone carving? Yeah, I can tell I get a little crazy and make up songs. Okay, so bone formation. So we're talking about endochondrial ossification. As this occurs, we saw the long bone structure multiple times, and I've alluded to the idea of this epiphyseal plate, and this is also called the growth plate. So this again is an area where bones lengthen. So when bones get longer, it's your epiphyseal plate that's getting longer, and you can see here that endochondrial ossification is a replacement of hyaline cartilage with bone. So you can see here the first kind of zone of you've got your first zone of resting cartilage, and then you've got proliferating cartilage, and next you have hypertrophic, which are going to have those mature chondrocytes in them, and then next you have the zone of calcified cartilage, and again this is giving rise to that more mature bone. So the old chondrocytes are going to be replaced by bones, so new chondrocytes are formed here. So you've gotten growth, your continuous growth here, and as they mature, you're getting longer bones that occur in this region here. So you've got your new diaphysis here. The whole diaphysis is kind of growing longer in that direction because you've got the maturity of those chondrocytes kind of coming down and lengthening bones as they mature. What's interesting is, like, here's a great radiograph showing the aphyseal plate at the femur of a 3-year-old. So aphyseal plates are one way in which people who, let's say if you were interested in, what's the words I'm looking for? If you're looking at, I'm going to just say it the most common way. So if you're looking at dead bodies and you're trying to age them out, you can look at aphyseal plates to be able to tell the age of somebody who's deceased, right? Somebody who has maybe a more active aphyseal plate. Now, obviously, this is going to apply much more to somebody like in their teen years or what have you. Obviously, size would give away a lot of age, but when you're basically 14 on, your age could be a little bit kind of up for grabs. So the aphyseal plates is one way that you can look at bone and kind of understand the age of a deceased individual. And so you can see here, you've got in the diaphyseal side, your developing bone in your aphyseal plate, your zone of calcified cartilage, your zone of hypertrophic cartilage, and then your zone of proliferating cartilage. And so this is your femur here, this is your aphyseal plate, and so your levels of developing bone is going to be kind of away from that. So this is your diaphyseal side and this is your aphyseal side. So this is kind of flipped compared to kind of the image that we're looking at here, because your development is kind of growing in that direction. So that kind of makes it a little bit, what's the word, confusing, but just make sure you have the diaphysis and epiphysis sides figured out, and that should hopefully in your mind make it a little bit clearer. But you can see how the cells kind of change throughout those different zones. So yeah, the growth plates, making bones longer. So if you think about bone remodeling and bone formation, you want to make bones longer, but you also want to sometimes expand the roundness of the bone as well. Oh goodness. Okay, so bone thickness. That's what it was. Thanks to the cooperative action of osteoblasts and osteoclasts. So going back to the first kind of definitions, osteoblasts are building the cells and osteoclasts are going to be carving the cells out. So here you can see the reductant in the periosteum create a groove for the periosteal blood vessel, so that blood vessel exists there. And slowly but surely you have a tunnel that's formed around those blood vessels using the osteoclast. But then you also have that expansion of bone that is being created by the osteoblast. So the osteoblasts in the endosteum build new concentric lamellae towards the center of the tunnel, forming new osteon. So you have more osteon that are formed here. And so this is going to create an osteonic canal. So remember when we go, I was labeling those images. One thing that you need to know what it is know what an osteon is, know what the periosteum is, and so forth. So trying to keep it as straightforward as possible. So osteoblasts are going to build and kind of create that material, and osteoclasts are going to destroy. Now, the next image is probably a much better image to show for that. So if we look at bone formation, again, this is the long bone that we keep looking at here. You have your diaphysis and your medullary canal that's present here. So in an infant, as the bone kind of grows in its, oh my gosh, I can't believe I can't think of the word. So the circumference, we'll say circumference of the bone, as it grows outward, you've got bone that's being destroyed by osteoclasts to create a larger medullary cavity, and then you've got bone formed by osteoblasts on the outer side of it. So as the bone continues to grow, you've got that medullary cavity that continues to grow as well. So osteoclasts are kind of carving out the center of the medullary cavity, and then your osteoblasts are continuing to add cells to the outside of that. And so that continues in time as the bone is formed. So I'm going to just throw out there that right now you'll watch this lecture, and I've kind of pointed out the things I think are most important in this part of this chapter. the terminology that I think are important, the things that I'll ask you to label. We'll probably go over this again in class because I know people are going to have those questions. What do we need to know? What can we kind of, ignore? Just recognize that your textbook goes into a lot more depth for each part of this. So if you are super interested in bones, or if you feel like my explanations during lecture just aren't doing it, our textbook is a great resource, as well as the videos that are included with Wiley Plus. So just make sure you're using all of those resources, because maybe they'll give you some depth that you're not necessarily wanting, but they may also explain things a little bit more clearly to make a light bulb go off in your head. So just use your resources as much as possible, as well as shooting me an email if you need further clarification. But we are going to discuss this Tuesday in class, and so hopefully if you have your questions, you'll come then and we can talk about it. But again, use all the resources that are kind of at your disposal to make sure you kind of understand this. So yeah, and I guess the place I was going with that is your book is going to go into a far greater level of detail. You do not necessarily need to know it to that level of detail. Usually what I'm presenting you in lecture is kind of the level of detail that I'm going to require you to know. I'm just kind of taking another look at my notes and making sure we've covered all the study guide questions here. Yeah, I think so. So if you have any questions or concerns, please feel free to reach out. Again, another plug is make sure you answer the study guides for Chapter 6 before you come to class on Tuesday or Thursday. Quiz 6 is due by midnight on Friday, and then the following week, homework 6 for the adaptive practice is due next Monday. I hope you all have a great weekend if you're watching this, and yeah, thank you so much for your time.